So welcome to Unit 1, Lesson 2, Data Representations. In this lesson, our learning goal is to represent and analyze data using dot plots, histograms, and box plots. You have two learning targets for this lesson. If at the end you do not feel comfortable with either of these two statements, please use class time to ask me for clarification on this so that we can make sure you've hit these targets and you're ready before we move on to the next lesson. Your first learning target is to be able to say, I can find the 5-number summary for data. And your second learning target is to be able to say, I can use a dot plot, a histogram, or a box plot to represent data. Again, if at the end of this lesson you have questions about either of these learning targets, please use class time to ask me for clarification. Before we get started, we need to make sure that we understand some of the vocabulary we will see. First, we have categorical data. Categorical data are data where the values are categories. For example, the breeds of 10 different dogs are categorical data. Another example is the colors of 100 different flowers. Now, these are considered categorical because if I asked you for dog breeds, you would give me answers like golden retriever, pit bull, chihuahua. These are categories. You're not giving me numbers. And on the second one, the flowers, you might say roses, tulips, daffodils. But again, you're giving me categories, not numbers. Next, we have the term distribution. For a numerical or categorical data set, the distribution tells you how many of each value or each category there are in the data set. Our next term is 5-number summary. The 5-number summary of a data set consists of the minimum, the 3 quartiles, and the maximum. It is often indicated by a box plot like the one shown, where the minimum is 2, the 3 quartiles are 4, 4.5, and 6.5, and the maximum is 9. This is going to be a very important vocabulary term. Remember that one of your learning targets is to be able to calculate this 5-number summary. So we need to remember that on the far left end, we have the minimum. On the far right end, we have the maximum. The two sides of our box, the left side is our first quartile, or Q1. The right side of our box is our third quartile, or Q3. And the line in the middle of the box is going to be our median. Our next term is non-statistical question. A non-statistical question is a question which can be answered by a specific measurement or procedure where no variability is anticipated. For example, if I ask how high is that building, there is one correct answer. So there will not be any variability in the responses I get. So it is non-statistical. If I run at 2 meters per second, how long will it take me to run 100 meters? There is only one correct answer here. I would divide the 100 meters by 2 meters per second, and I would get the answer 50 seconds. There will be no variability in the answer, so it is a non-statistical question. Our next term is numerical data. Numerical data, also called measurement or quantitative data, are data where the values are numbers, measurements, or quantities. For example, the weights of 10 different dogs are numerical data. When you work on your group project for this unit, you are going to need to design a question that will give you numerical data. That way you can plot it on your dot plot, your box plot, and your histogram. So when your group is deciding on a question, ensure that the responses you would get are going to be numerical responses. Our next term is statistical question. A statistical question is a question that can only be answered by using data and where we expect the data to have variability. For example, who is the most popular musical artist at your school? This is going to be different for most schools. So there is variability, so it is a statistical question. When do students in your class typically eat dinner? People are going to eat dinner at different times, so you are going to get variability in your responses. That means it is a statistical question. Which classroom in your school has the most books? This will change depending on the school. So you're going to get different answers. So this is a statistical question. When your group begins their project and you are trying to decide on your question, you need to ensure that it is a statistical question. You need to know that you are going to get different responses from different people. Now we are going to start on the practice problems for Unit 1, Lesson 2. The dot plot displays the number of bushes in the yards for houses in a neighborhood. What is the median? So we need to remember the median is the middle result. Just like on a road, the median is in the middle. So we would count the total number of dots, and there are 20 dots on this dot plot. If you divide that in half, that would be 10. So we need 10 dots to be to the left of our median, and we need 10 dots to be to the right of our median. So I'm going to start down here at the left, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our median would be right here between these two dots on the number 8. That means the median is 8 bushes. So we could say that the typical house in this neighborhood has 8 bushes in the yard. If you have any questions about how to find the median from a dot plot, please use class time to ask for further clarification. The data set represents the shoe sizes of 19 students in a 5th grade physical education class. Create a box plot to represent the distribution of the data. So, if we are going to create a box plot, we need the 5-number summary. That is minimum, first quartile, median, third quartile, and maximum. So the first thing you need to do is make sure that your numbers are in order from least to greatest. In this problem, they've already done that for us. So we can see that our minimum number is 4. We can see that the maximum number is 9. Now we need the number that is in the middle. If there are 19 numbers, then that means the 10th number will be in the middle, because there will be 9 numbers smaller and 9 numbers bigger. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, this is our 10th number. There are now 9 numbers smaller to the left and 9 numbers bigger to the right. So my median is 7. Now to find Q1, I need the number that is in the middle of the left side. So if we look, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in between the minimum and the median. So right in the middle would be between these two 6s. We can see 4 numbers to the left, 4 numbers to the right. It's in the middle, and since these are both 6, that means the Q1 is 6. Now to find Q3, we do the same thing on the right. There are 8 numbers between 7 and 9. So 1, 2, 3, 4. If we draw the line here, there are 4 numbers to the left. There are 4 numbers to the right. So we need the number that is halfway between 7.5 and 8. So if we add them together and divide by 2, we get 15.5 divided by 2, which is 7.75. So our Q3 is 7.75. Now we need a number line. We know that we need it to go down to at least 4, so I'm going to start it at 3. And we know we need it to go to at least 9, so I'm going to have it go until 10. Now we put a dot for each of these, or a line for each of these 5 number summaries. So we've got a line at the minimum, which was 4, a line for the Q1 at 6, a line for the median at 7, a line for the Q3 at 7.75, so just before the 8, and a line at 9 for the maximum. We draw our whiskers on the left end and the right end, and then we connect the middle part together as a box. And this is how we create a box plot to represent a data set. If you have any questions about how to do this, please use class time to ask for further clarification. The final practice problem says the data set represents the number of pages in the last book read by each of 20 students over the summer. They give us the number of pages, and they ask us to create a histogram to represent the distribution of the data. Now, you will select how big your sections will be, or how big your buckets will be. It could be every 10, 20, 30. It's up to you. We look at our numbers and they're already in order from smallest to largest. And we need to be able to go all the way from 163 to 431. So I'm going to make my buckets every 30. I'm going to start at 150, and then I will do increments of 30. Once I've made the bottom, then I need to make a vertical axis as well. And I'm going to make these every 1. So we're looking how many times a number shows up between 150 and 180, but less than 180. So that would be 1, 2, 3, 4, 5. So I'm going to go up to 5. And that's how tall this one's going to be. Next, we're looking 180 until less than 210. Well, that only happens once. So this bar only goes up to 1. Next, we're looking at least 210, but less than 240. And that happens 1, 2, 3 times. So we're going to go up to 3, and this bar is going to be 3. Next, we're looking at least 240, but less than 270. And that happens twice. So we find 2, and that's how tall this bar will be. Next, we're looking for any numbers that are at least 270 but less than 300. And that happens once. So we find 1 to the left, and we draw this bar to be 1 tall. Now we're looking for numbers that are at least 300 but less than 330. And that happens 1, 2, 3 times. So we find 3 on the left, and this bar is going to go up to 3. Now we need numbers at least 330, but less than 360. That only happens once. So we find 1 to the left. This one is only going to be 1 tall. Then we need numbers that are at least 360, but less than 390. That happens twice. So we find 2 to the left. This bar is going to go up to 2. Then we're looking for numbers at least 390, but less than 420. That happens once. So this bar is only going to go up to 1. And finally, numbers that are at least 420, but less than 450. That happens once. So again, this bar is only going to go up to 1. And this is how we create a histogram. We decide on how big each category is, and then we count how many times the numbers that are as big as the left number, but less than the right number, how many times numbers fall into that category, and that's how tall we draw the bars for that category. If you have any questions about how we did anything on the practice problems for Unit 1, Lesson 2, please use class time to ask for clarification so that we can make sure you're ready for the next lesson.